metal appear first, cast duration in the first taphole become shortened, and the later taphole cast prolong. So there is a abnormal discharge from the bottom of the furnace and which gets translated at the top of the furnace in terms of burden descent. So a sort of asymmetric conditions keep on generating in the furnace and which is really difficult and detrimental for the blast furnace to optimize its production and productivity. So challenge is we have to take care of such abnormal situation as quickly as possible. This is one of the situations. Situation may be manifold, but this is a very peculiar situation. Mostly number of furnaces undergoing such type of symptoms mostly. And hence today's our project is to take care of the entire problems, especially in two category. One category is maintaining, proving your equipment's parameter, hydraulic guns or electric guns, whatever you have, the equipment working parameter should be okay. So we are coming to the second slide where equipment check and ensuring perfect taphole closing, opening. Today our journey begins with a critical aspect, ensuring precision and taphole management. We will discuss key parameters like hydraulic pressure, ram movement and drill machine inclination, which is one of the very important parameter. And I will suggest that first of all, if such situation occurs, operator must have to ensure that inclination of drill machine with respect to taphole spool is same. That is in the both taphole it's same. That is one of the most important parameter. And thereafter, the plugging device, that is a clay gun, ram pressure, the volume of the clay holding by the barrel, and ram movement, traction force of the drill machine, all these parameters are symmetrical or not. So this is going to be really very important for us, and we must have to meet symmetrical situation in both taffoles, right from out external parameters like a spool should be okay, inclination should be okay, ram movement of the barrel gun should be okay, extrusion from the nozzle should be perfect and should be similar in the both taffle, volume holding by the barrel should be same. Many times what happens, the ram top is getting a build up and in the process barrel hold a lesser clay, and operator if you want to put more volume, more liter of clays in the taffle, it fail because the movement of ramp mostly are connected with our indicators which shows the movement of the ram, and mostly we are misguided by such type of build up on the ram. So we have to open the barrel after taking out the gun. When the barrel gets empty, we have to take out the cover and we have to introspect the ram top is getting built up with some older clays or not. It very occasionally happens, and thus we have to ensure that there is no reduction of such barrel volume is there. And as I told, rest all parameters related with the equipments is to be checked whether they are correct or not. So we will discuss the key parameter like hydraulic pressure, ram movement and drill machine inclination as I mentioned. So this is to be ensured. Now let us explore measures for optimizing the hearth permeability, and which is also very important aspects, and this is I think rather more related with the remedial measure, I will say. So if such type of things happens, many times we come across that what is to be done. So as I have already suggested in slide 1, based on our experiences that this system is to be checked first, and now if such things occurred, now some remedial measure we can try, and this is based on the facility available to the furnace owners or furnace operators. So one of the thing is that we can go for the lean slag, and obviously it will help in taking out flushing some of the alkalis which are also detrimental in disintegrating the coke structure down below and making more dirty voids, especially the metal and slag could not able to pass through those dirty grades of the coke, and that is the reason at that time we should have some lean and hot practice. It will have got a basically good advantage of flushing a few alkalis part from the bottom part through the slag. So this is one of the advantage of practicing a bit lean slag. Second thing, a hard burn sinter means if you, we might have a something more like a 11 short of 11 part 11% of FeO more or less in the sinter. Of course, such type of sinter will be pretty inferior to reduction, obviously because all pores will be covered. And but such type of sinter may help to consume your bottom coke carbon, and in the process it may generate some voids in the dead man, and overall we can say in the bottom part of the furnace, that is in the hearth. So this hardboard center may help in terms of like FeO plus C FeCO. So the coke once get consumed in the bottom grid, their generation of more voids. And of course, if we have got a facility of furnace charged with the two type of coke where surface and center coke both are available, then we can choose to charge some center coke and especially in the center of the furnace, because we are adding this bigger size coke for the deadman permeability. Hence, it must be charged in center. Carbon analysis is also a must, which can give us a lot of indication whether the metal drip down to the bottom part of the hearth, and again it's siphoning and getting lifted to the taphole. This is how the siphoning of the metal from the hearth comes out of the taphole. So in the process, when our hearth is clean, the metal rivulets has to cross more distances. In the process, they might have a pick up more carbon. So this is how one way we can counter, just simulate in our mind that yes, hearth is a bit cleaner with the analysis of carbon. And we can go through a regular assessment of our temperature and carbon analysis, that how the percentage of both component is steady, and if this remains steady, it is a very strong outcome. It is a good symptom for the healthy furnace. Now if we have a hearth evacuation model available with our control room, we could able to also access on a regular basis that shift wise, hour wise, or cast to cast wise, how much slag is getting evacuated, and whether it is patch up, it is matching with our normal furnace evacuation quantity or quality or not. So this also guides us in normalizing our furnace from such abnormal situation. Now DCA calculation may also help if we have, because it is navigating the picture of the hearth, the anatomy of the hearth, and very important. If the furnaces are well equipped with your thermocouples and they remains in a very healthy shape and size, then we can also correlate the center pad temperature at a various levels. That is difference of each interval in the center, and the similar pattern if we could able to find out from the wall area, then we can correlate the what sort of movement is there, whether metal has got a more peripheral movement or metal is passing through the dead man grid or not. So such type of things can be evaluated once we keep on monitoring these temperature profiles. So this is what all I mean to say, and this sort of abnormal situation is really very painful, and we must have to act very promptly. So this is all.